Okay, so back to this. We have our inner and our outer core. Our outer core is a liquid layer made up of iron and nickel, and it causes our Earth's magnetic field. So convection is occurring in this layer. So we have that flow of hot iron and nickel going on. And that flow and that movement of the metals causes our magnetic field of the Earth. The inner core is solid. So despite it being the hottest part of a layer of the Earth, there's so much pressure that it's being compressed into a solid. So continental drift, Alfred Wegener proposed the idea in 1915. Pangea, I'm sure we've all heard of it as the OG original continent. All the continents were together to begin with and ended up breaking apart. And he came up with some of this evidence to support his ideas. The first one is the continental puzzle, that there are similarities between coastlines of different continents that doesn't make sense unless they formed one continent to begin with. Matching fossils found on different continents, again, that didn't make sense unless the continents were together at some point. Here we can see an example of that, of the matching fossils. Some fossils here in South Africa or South America are also found in Africa. Some fossils from Africa are found here in India, and so on and so forth. You can see that pattern through here. The other part of evidence is the rock types and structures. So there are mountain ranges that abruptly end at one coastline and then continue on at another coastline. This is seen here. The Appalachian Mountains in North America are connected over here, British Isles. All these pieces seem to fit together. So it would make sense that at one point it did make up just one mountain range. The other part is ancient climates. So glaciers, as they move across the Earth, they create these scratches in the grooves as they move, and they move sediment across large areas. And we find glacial till, which is that the scratches in the grooves in the sediment, in places like Southern Africa, South America, India, and Australia, places that would have no reason to have glaciers unless at some point they were closer to the North or South Pole. So we have plate tectonics kind of came on 50 years later as an explanation of how this occurred. And basically what it's saying is in the lithosphere, that top layer of the crust and the upper mantle, this creates plates. So there are different plates there, and they're going to move because of the convection that is occurring underneath them in the asthenosphere. There are 7 major plates. You don't really need to know this, but it's interesting to see that most of the plates take up an entire continent and part of the ocean between 2 plates. So the South America plate takes up all of South America and part of the ocean here. The Africa plate takes up almost all of Africa and much of the ocean surrounding it. Plates move about 5 centimeters per year, so this isn't a very fast process whatsoever. That's about how fast your fingernails grow, if you're interested. So it's not a very fast process at all, and it's driven by convection. Again, the hot material of the lower mantle moves slowly upward, and the cool material moves downward. This plate movement is responsible for things like earthquakes, volcano formation, and mountains. There are 2 different models for convection. This is a simple model on the left-hand side, whole mantle convection. We have magma pluming up, coming all the way up here, and then we have parts of the plates here that are going down. So it creates this kind of very simple pattern of the plate going down, magma coming up. Deep layer model is more complex, so it shows convection occurring at different layers of the Earth. Again, along the same ideas, but a little more complex and intricate. Okay, we're going to come back to this.